30 healthy adults participate in our study. They were all IRB approved. So we started out by having them fill out the consent form and Part Q, or just the eligibility requirements. We took their mass, their height, and we asked them how comfortable they were while biking on a scale of 1 to 10, and in water on a scale of 1 to 10. We then assigned initial conditions, so some participants started in the water or some participants started on land, and we counterbalanced this just to account for these learning effects. And after this was all done, we familiarized them with the procedures. So our setup was slightly complicated. We basically had to find a way to set resistance and quantify it without putting an electronic bike in the water. So what we came up with, or what Dr. Henry came up with, is this bike that sits up on this platform, and we can set the resistance from up here, and this chain system sets the resistance of this bike in the dunk tank. So we would fill this up with water and pump it out for the land condition, and this bike would set the resistance for this bike. So some of the constants, or the things we wanted to keep consistent throughout all the participants, was the depth of the water. We set this slightly at or above the iliac crest so that the knees would not break the surface of the water. We had the land conditions at just room temperature, so 20 to 21 degrees Celsius. And for water, we set it at 32 degrees Celsius, or what's considered thermoneutral, so your body doesn't have to heat up or cool itself down. The seat height was set based on the participant at full leg extension with a slight knee bend, and then the participants were instructed to keep the same position at all times. For the water procedure, we started out by taking the resting flow volume loop. So we took about 3 to 4 of these, just repeating for consistency. We then did the maximal voluntary ventilation test, and because you can only do one of these, it sometimes elicits dizziness, so we only did one, and we had them rest for 5 minutes after. We then took their baseline oxygen consumption and CO2 expenditure and minute ventilation. So if you can see here, this computer was taking their breath by breath analysis, or taking their breath, and we had them hooked up to a mouthpiece that interfaced with the computer. So their breath was coming in through these tubes and being collected by this program. So beginning testing, after they had sat on the bike and just breathed into the apparatus, we had them start at 0 watts. So if you set your bike to the lowest gear, that would be like 0 watts. It's kind of like you can barely keep your feet on the pedals. You're just, it's hard. So in itself, yeah. So it's not hard in terms of resistance, but kind of coordinating. So they started at that level and then went straight into the 50 watts, which is slightly more resistance. Not too hard, but just a little bit more. And then 100 watts, which is when they kind of started sweating. They were working a little bit harder. And this lasted for about 2 to 3 minutes, or until they reached steady state, so when their physiological functions weren't fluctuating anymore. And they pedaled at these resistance levels at a speed of 60 revolutions per minute. And while they were doing all this, we were collecting their oxygen consumption, their carbon dioxide expenditure, their heart rate, and their minute ventilation. And then we also collected their rate of perceived exertion, 1 minute and 30 seconds into each phase. So for the land procedures, it was the exact same process. We actually just pumped this water out so they were sitting on the same bike, and did the same exact procedures over again. And this test was performed on the same day with appropriate rest period in between. For data analysis, we took the final minute of heart rate and minute ventilation and averaged it for each participant at each phase. We then took that and we analyzed the data with a 2-way repeated ANOVA. And for each variable, we also analyzed it with a post-hoc test or paired t-test. So it's important to note that there is a significant difference between all of these resistance levels, which is good because as you exercise, your physiological functions should be increasing over time. But these asterisks down here is what we're most concerned with. It's the significant, or indicating the significant difference between land and water. So for minute ventilation, we found that at higher resistance levels, minute ventilation was higher in the water. So as they were pedaling in the water, they were breathing harder and working harder. So RPE was consistent with this, which is good. At 50 watts and 100 watts, RPE was higher in the water. So as they were pedaling in the water, they were feeling like they were working harder. For heart rate, it was a little bit more interesting. At rest, we found that heart rate was actually lower in the water, which is consistent with previous knowledge about decreased heart rate because of easier blood shunting to your heart. So that was kind of a good validation of our data. And then as it increased over the 0 watts and 50 watts, there was no significant difference between these two land and water conditions at these levels. But at 100 watts, we found that water heart rate was actually higher than heart rate on the land. So what we attribute this to is a lower heart rate at rest is causing, well, a lower heart rate is this is basically having to catch up with the land heart rate. So it is, water heart rate is faster, but because of this lower resting value, we're not seeing a significant difference yet. So basically at the 100 watts, that's when you start seeing the significance between heart rate in the water and heart rate on land. That makes sense. So basically what we found is that at resting values, heart rate was consistent with previous knowledge, which is good. But at higher resistance, we found that physiological functions increased in the water. And so we mainly attribute this to the additional drag force that the water is adding to the resistance of the bike. So because of this additional drag force, your physiological functions are going to be greater in the water. So this information will add to just the general knowledge of water exercise, but there obviously still needs to be things that are further investigated. Things like this could be higher resistance levels, just to see how this continues to be different in land and water, or even changing the cadence or temperature, just to kind of add to the knowledge. And this addition of knowledge will help us better understand rehabilitation plans and how to prescribe them more safely, and just for the general population's well-being while